Hello everyone, welcome back to Physics 11. So today we're going to be looking at another type of force. So this is part of the force applications, and this is going to be the force of friction. Now I already mentioned friction when we started talking about Newton's laws, that normally it's going to be an opposing force, right? Whenever we have a force that's been applied, it's going to be opposing basically the direction of motion. So let's talk in more details about friction. So what is friction? So first of all, friction is created whenever two surfaces try to move past one another. So let's say you're sliding an eraser along the whiteboard, right? That's the surface of the eraser, the felt against the plastic or whatever the surface of the whiteboard is. Or for example, the tire rolling along the road. So we have rubber and pavement. And whenever again you have two surfaces interacting like that, there's going to be friction. Now on the microscopic level, it's actually really small irregularities that you can't really see them, but it's going to be actual interference or impedance between these two surfaces. So there's actually mechanical interlocking that's going on that prevents the surfaces to move smoothly. So that's why the rougher the surface, the harder it is to move along it. But for example, if you think about something like ice, which is really smooth, it's really easy to glide on it or to skate on it. So here's a little kind of microscopic view of, let's say, this could be the pavement and the rubber from a tire, right? So on a microscopic level, there's tiny irregularities that kind of interlock together, which creates friction. Now, friction is given by the following equation. So force of friction equals mu times normal force. So we say mu Fn. So the mu here, this Greek letter mu, is what's known as the coefficient of friction. Okay, this carries no units. Now we already know about the normal force. Normal force is always perpendicular to the surface. So remember, you don't have normal force if you have free fall, so you have to have some sort of surface, and it's always going to be perpendicular, so 90 degrees to the surface. So that's pretty much it as far as the equation. It's pretty simple. So force of friction equals mu Fn. And again, the mu, normally you're going to be given this value, and this is something they had to actually derive through experimentation. So people made some experiments, they calculated the mu value, and in a lot of questions you're just going to be given the mu value. So you don't need to really, in a lot of questions, you just need to calculate force of friction. Now there are two types of friction. There is static friction. So static means that it's standing still, so it's not moving. So the friction force that must be overcome in order to initially move an object. For example, think of the time when you had to push something. Let's say maybe you're helping push a car or a large object or something like a piece of furniture. It's harder to start to push the object at first, and then it gets easier once it's in motion. So the initial friction they had to overcome, that's the static friction. And then the next one is called the kinetic friction, which is the friction of motion. So whenever an object is already in motion, we still have friction, but the value is going to be a little different. So normally static friction is going to be bigger than kinetic friction. And if you have the same object, that means that the only difference is going to be the mu value. So we have, again, force of friction that's static is going to be bigger than force of friction that's kinetic. And again, if you're talking about the same object, the mass doesn't change, the Fn doesn't change. The only thing that's going to change is your mu value. So your mu for static friction is going to be bigger than your mu for kinetic friction. So pay attention to what kind of mu coefficients you're given. Are you given the static mu value or are you given the kinetic mu value? All right, so let's take a look at one example and see what we can do with this. So this question here, it says here they have a box or a block that's 3.75 kilograms in mass. It's pushed along a tabletop with a surface of 45 newtons, and the coefficient of friction is 0.65. Now notice here, it doesn't say what kind of coefficient this is. Is it kinetic or static? But because we already know that the box has already been pushed, we can assume that it's kinetic, even though for this part it doesn't really matter. We just need to find what the value is. But in this case, you're actually going to be finding the force of friction of motion, so it's going to be the kinetic friction. So this question has two parts. It says find the force of friction, and then part B says find the acceleration. So finding the force of friction, first let's make a diagram, include all of the forces. So let's make just a quick diagram, draw a box. All right, so that's our object. Now, perpendicular to the surface, so here's our surface, is going to be our normal force. So remember, for your free body diagram, make sure you include all the forces. We're going to have force of gravity acting downward. Okay, let's say we're pushing the box to the right, so we're going to have our force applied to the right, and then friction is going to oppose this force in the opposite direction, so it's going to be in the opposite direction, force of friction, not gravity, to the left. Now our motion here is going to be to the right, so let's make our positive up and to the right. All right, so notice here that the question only asks us to find the force of friction. So we don't need to write the F net equations, not just yet. We're just learning about the force of friction here. We're just asked to find what the value of this is. But we do know what the force applied is. We know that this is 45.0 newtons. So in order to find force of friction, we need to know our Fn. So let's start with the Fn value. Now this is something I saw in the quizzes and people are still kind of confused, it seems, I don't know. They're using this separate from this, okay? These two notations are equivalent. If you're gonna use the sigma notation, all you have to do is write either x or y or z. In this case, we're only gonna be dealing with 2 dimensions. For example, I'm gonna start with the F net for y. If you wanna use this notation, you actually have to say this is the y direction. So I know what you're talking about, right? You can't just write F net and then have sigma notation somewhere else. You have to pick what kind of notation you want to use. So personally, I would rather use the sigma notation because all I have to do is just write a subscript to indicate what direction am I referring to. So I'm not going to use F net as much. I do prefer the sigma notation because this is all I need to do to show what direction I'm talking about here. So for the y, the F net, we have two forces in the y direction. We have our normal and our Fg. And even though, like I said, in physics 11, a lot of times we're just going to be dealing with Fn equals to Fg, you still have to show why that is, right? So in this case, the block is now moving up and down. So when you write your F net, we have these two forces acting together, right? And we have acceleration in the y direction here. But because again, well, we don't have acceleration in this case, but we had to write it down and then say there is no acceleration because it's not going up and down, it's only moving left, right. So this goes to 0, and therefore we get the following, get our Fn minus Fg equals 0, and then we can say Fn equals Fg, which then equals to mg. And then you can plug in your actual numbers for the mass, which is 3.75 times 9.8, right? And you can get your value for the normal force, okay? Or in this case, I'm not going to do that. Actually, this would be, this is another thing that I noticed. People splitting their work. They calculate their Fg somewhere on the side, and then they come back and write their F net. Do it all in one line. They should all be the same workflow that you're showing when you do your F net for the y, right? So in this case, if you were to calculate the normal force, we get 3.75 times 9.8 is 36.75 newtons. Now in this case, we have 3 sig figs here. So this would be rounded to 3 sig figs. But we are looking for the force of friction. So we could also actually included this equation in the next FNet equation and only plug in numbers once. So normally I always say solve for the unknown first and then plug in numbers as your last step. So I kind of did not follow my rules here, but let's take a look at the next equation, which is our FNet in the x direction. And in the x direction we have our FA minus our force of friction, and this is going to equal to the mass of the object and acceleration in the x direction. All right. Now in this case, that would be our next step actually. So that's going to be part B. So for part A, all we need to do is find the force of friction, which we can do because we already know our Fn. So let me backtrack here. Our force of friction is going to be mu Fn. Plug in the numbers for mu, 0.65. Plug in the value which is found, 36.75. Now remember, this is 3 sig figs there. So we have 2 sig figs here, 3 there. So the final answer should be 2 sig figs. So we get 23.89. But we're going to round this to 2 sig figs, which is going to be 24 newtons. All right, so that's going to be our force of friction. So once you know your force of friction, we can then plug it into our FNet for x direction and then find the acceleration, because otherwise we wouldn't be able to calculate our acceleration. So on the next page here, I'm going to take my answer from part A, 24 newtons for the force of friction. Well, it's not the next page for you, but I'll have to rewrite it. So I have my FNet. So again, we had our force applied, positive, force of friction was negative, and this equals to the sum of the two forces. So this is the resulting force, m times a, and we asked to find the acceleration, right? Part B is asking for the acceleration. So we know what the value of FA is. We found what the friction force is. All we need to do is find the acceleration. So basically just the one unknown, so we had to divide both sides by m. So we get FA minus f of f over the m to get our A. So let me write the A on the left. Plug in the numbers for the forces. So again, we had 45.0 here minus, what do you get, 24 over the mass, which was 3.75. So notice at the top we have least number of decimals. Actually, hold on. Maybe to make our calculations more accurate, we shouldn't be using the rounded answer here, but just keep in mind that it should be no decimal places. So when you round your top value, you should have no decimals. So we're going to have 23.89. All right. So in this case, 45 minus 23.89, we get 21.11 over 3.75. Now notice, like I said, I used this value here, but there's no decimals in this second number here because of sig figs. So your answer is going to be 21, which is 2 sig figs when you actually round your final answer here. So it's going to be 2 sig figs on the top. So our final answer should have 2 sig figs because this is, it's going to be 2 sig figs. This one is 3 sig figs. Because we're dividing, the answer should be 2. So anyway, 21.11 divided by 3.75 is 5.629. 5.629. And this is meters per second squared. But again, we're going to round this to 5.6 meters per second squared. That's going to be our final answer for the acceleration. All right, so now we learned how to find the force of friction, calculate the force of friction given the mu value. And then again, we do the same steps as before. We need to have our free body diagram. We need to have our F-net equations, and then solve for whatever else it's asking us for. For example, in this case, the acceleration. Now, one thing to remember with the free body diagrams is that if you're not sure what acceleration is asking you for, is it asking you for the y acceleration, is it asking you for the x acceleration? Normally, it's going to be the x, right? Because normally, we're going to be dealing with objects moving left and right. But think of which way is the object moving. Is it moving in both directions, which is not the case for physics 11? It's going to be 1D only. So it's always going to be either x or y. So in this case, the acceleration that this is asking us for, even though it doesn't say, this is in the x direction. Okay, so you had to think about the question before you start solving for it. So if you're confused about which acceleration it's asking you for, think of the direction of motion. Is it moving along the x-axis or is it moving along the y-axis? So let's take a look at another question. This is example number 2. And this one says a 0.2 kilogram puck is pushed along a sheet of ice with a force of 0.24 newtons. If it moves at a constant velocity, find the coefficient of frictions. For example, here it doesn't say is it moving along the x or the y, but obviously if you think about a puck on ice, it's going to be moving along the x direction, right? So we can say that our x direction acceleration is going to be 0 because the velocity is constant. But it's also not moving up and down, so we can also say the acceleration in the y direction is also 0. So let's start with the free body diagram. Here's my puck, right? We have our Fn perpendicular to the ice. We have our Fg. Let's say we have our force applied of 0.24 newtons, so my Fa here. Okay, and then what else we have? Force of friction, which is going to be in the opposite direction of the force applied. All right, so let's make this positive up and positive to the right. Again, really important to indicate which way is positive. So a lot of people are forgetting that. Next, write your equations. So let's write the equation for x. So my F-net in the x direction is going to be the force applied minus the force of friction. And this equals to my mass times the acceleration in the x direction. Now I know that this part is going to go to 0 because the velocity is constant. So I can then rewrite this and say, okay, therefore my Fa minus f of f equals 0. Okay, and then we can rewrite this one more time and say, well, I can also say that my Fa is going to equal f of f. And f of f equals mu Fn. But now I'm stuck. I don't know what mu Fn is, right? I know the mu. I'm sorry, I don't know the mu. So all I know is just the mass. So I need to find what this value is going to be, right? So know that we need to find our force of friction. So we need to find our normal force. So now we need to write the F-net for the y, Fg. And again, we know that this part will go to 0. Therefore, we can say that Fn will equal Fg, which will equal m times g. All right, so now we have these two equations. And again, we're looking for f of f, right? So if you take these two, right, we can say that, all right, f of f is equal to mu Fn or mu, well, let's write it out, mu Fn equal to mu times mg, right? Now, we know what this value is. We know what Fa is. So we can replace our FA, or these two are equal, right? So we can replace this value. We know that. We know the mass, we know gravity. We're going to find the coefficient of acceleration mu. So let's rewrite this. I guess we should write this in terms of FA, not F of F. But let's rewrite it on down here. We have our mu equal to mg over f of f. And again, because FA equals f of f, I should have used the FA there, but that's okay. Let me rewrite it one more time. All right, so there you go. We got our mu equal to I made a mistake. Let me fix that. The other way around. Mu is going to be equal f of f divided by mg. All right. So basically, we're going to take our 0.240 newtons divided by the mass times the gravity. So our mu equal to 0.240 newtons over 0.200 times 9.8. So again, when you do the calculation here, the 9.8 is a constant, so we're not going to count it towards sig figs. So it's just going to be the mass and the FA in this case. So both of them had 3 sig figs, so the final answer should have 3 sig figs. So I got 0, 1, 2, 2. So this is the value that I got for my mu, 0, 1, 2, 2. And again, this is without any units, because if you look at our calculation here, we had newtons on the top, we end up with newtons on the bottom, so newtons and newtons cancel away, and we're left without any units. So that's question number 2, where asked us to find the coefficient of friction. So again, you had to start with the equations, your F net equations, go through the steps solving for the mu value. Now I know I could have maybe done this a more elegant way a little bit, but solve for the mu first and then plug in numbers last. So you have to do just one calculation instead of multiple calculations all over the place. All right, so let's take a look at the last example here that we have. In this case, we have a 1.1 kilogram textbook that's held against a vertical wall with a force of 45 newtons. And what is the coefficient of friction between the book and the wall? So in this case, here's our scenario. We have our wall here, and the book is being pressed against this wall like so. So let's take a look at what forces are acting on it. Of course, it's going to be gravity acting down. We're going to have our applied force. Now in this case, you're pushing the book against the wall, so the applied force is actually this way. So this is going to be our FA, right? Because you're pressing against the wall. And then perpendicular to the wall is going to be our normal force. So normally we see the object sitting on a horizontal surface, but remember the Fn value or force is always going to be perpendicular to the surface. So in this case, our Fn is going to be pointing to the left. And now we have one more force, which is friction. And in this case, friction is going to be acting against gravity. So friction is going to be pointing up. All right. So again, the question says, what is the coefficient of friction between the book and the wall? So in the previous example, we found the mu, which was on the horizontal surface, right? Now we had to find the mu, which is acting against a vertical surface. So let's start with our equations. Our F net for y direction. Let's make this positive up and positive to the right. So we have positive direction, we have force of friction. We have the gravity pointing down. Now this is not moving, so we know that their acceleration is going to be 0. because it's held against the wall, so it's not being, it's not in motion. So we can write the equation and then say that this is 0. So therefore we can say that F is gonna equal Fg. All right. And next we need to know, I guess I should start with the x direction so we could find the Fn first, but that's okay. For the x direction we have the forces F applied minus the normal force equal to mass times the acceleration in the x direction. And again, it's not moving, so the acceleration is going to be 0. Therefore, we're going to get this equation where Fa equals Fn. Now we know what the value of Fa is. It's 45 newtons. So the next step we can do is then, okay, since you know your Fn, we can then find our force of friction, or replace it into the force of friction equation. And let's do that here. Let's do it this way. F of F equals mu Fn, right? And since we know Fa, we're going to replace it with mu Fa, okay? And because we know that F of F equals Fg, we can also replace this with Fg equals m times g. We can take this part here, Fg equals mg, and equate it down here, right? So I wanted to put everything together first before I solve for mu. So now we know our Fa, we know our m, we know our g. The only unknown is the mu. So let's solve for mu. It's going to be mg over Fa. So again, now we can plug in the numbers for the mass. 1.1 times 9.8 over 45. Okay, so we end up with 1.1 times 9.8 divided by 45. We get 0.23955 repeating. 0.2395 repeating. Now we do need to round this to proper number suffix, which is going to be 2. So it's going to be 0.24. So again, that's going to be our coefficient of friction. So if you have any questions on this, or if any of the steps are confusing, make sure you post a comment. Otherwise, make sure you do the worksheet 5.3, force of frictions. There are 9 questions, and there is a section in the textbook. I don't know the section number, but I'll post it in the comments so you can read the section textbook as well on this.